The interesting thing about weather systems is, in terms of the history of modern weather reporting, is that it developed around World War I. And so the whole terminology of weather systems is derived from that military context. So people talk about fronts, and those fronts are the interaction of cold air masses and warm air masses. And this tends to be a lot more dramatic in the northern hemisphere, where the cold air develops in the Arctic in these big cold pools of air. And in North America, it's especially dramatic because it's the only place on the planet where Arctic air systems actually impact directly on and with tropical air masses right in the central part of North America, which is why you get such dramatic storms and tornadoes there commonly, and they're so rare in the rest of the world. So the reason this occurs is geography, because across Asia and Europe you get these mountain chains that run east-west that separate Arctic air masses from tropical air masses, and that's not true for North America. So it's a great example for how this works. And so the tornadoes, which you've probably all heard about, ravaging the Midwest, they just keep getting bigger and bigger, and that is driven by that contrast between warm air and cold air. And of course, cold air is denser, and it actually drives a wedge underneath the warm air. And so as that warm air rises, water condenses, and it releases energy, which we refer to as latent heat. And that energy is what drives those storms. And so that's one interaction that you can think about in terms of just regular weather systems. We have the similar weather systems here in Australia, but they tend to be maritime air masses that come in, and they're not as cold and dry as they're coming off the Southern Ocean as those Arctic air masses that you see coming down from the north in the northern hemisphere.